Hi, my name's Dirk Howard. Um, I'm pretty new still to Python, and I volunteered to talk about the Python PZ or the time zone definition modules. Um, Basically, what I found is that the time zone modules are really good for helping you output and localize a time um, to display in a particular time zone or a particular um, region so that you're getting a good display of information. Uh, it is probably a mistake to design your application to be doing a lot of arbitrary management of your time based on foreign time zones or localized times. Um, Best use that I was seeing within the instructions were to try to keep your main calculations in a UTC, your main storage of time information in a UTC, and then use the PyTZ when it's time to display to the users. So using the PyTZ really is pretty simple. It's just a matter of getting it installed. You can use the easy install or the pip install to get it going, and then can just begin to um, use the items by importing. So taking that example that they have um, on the SourceForge webpage from that, um, we would import from uh, from date time. We want to have date time function and the time delta, and then from PyTZ, we want to import the time zone, and then we're just going to import the rest of the PyTZ components so that we've got access to those. One of the first things you'd want to do is maybe to define a time zone that you're going to work in as far as what you're going to um, be playing with. So as I said earlier, using a UTC is a good idea to have that as your base point for your calculations and kind of your point reference of what you're going to be doing. So the PyTZ does have a UTC defined for the UTC zone. So if we take a look, it knows about that straight out. If I want to set a particular time zone based on the Olson time zone specifications, I can do that by saying that I want to have a time zone and then give it the standardized um, naming convention that it would have. So I can, or I could set this. I don't. That one I was really kind of reaching for. So we've got yeah. Okay, so I've got a mountain time zone, and I also have this Amsterdam zone. Let me just get a format set up so that we can do some um, time printout. So setting up a local date time, I could set that equal to uh, a mountain, and we'll tell it to localize. And if we use the date time function, we can put in information. So we get if we do a print on the local date time with a string format, oh, you could type DIR open from Office for confusing to see what it has. I don't know.
STRF time,
Oh,
STRF time, one day.
there we go. So that's giving me the format for that local time.
So, okay, back halfway up the screen, you said you created a new datetime object and you gave it a wall clock time, like a local time, right?
Mm-hmm.
And then when you say localized, it tries to interpret that in the time zone that mountain represents. In this case, U.S. mountain.
Right.
So what happens if you give it a time that does not exist in that time zone? Like if you give it the date of jumping ahead, spring forward, and then you say like 2:30 a.m., what happens?
Good question.
I always wondered that how it's treated to begin with.
See, that's where the recommendation is to use the UTC.
Yeah.
Because if you take a local time zone, you can push it to a UTC and then use your UTC as your point of counting, date arithmetic, etc. And then displaying information back out, use the PyTZ to localize.
The localized then store it in UTC.
Well, yeah, but not quite, because localize is taking a local time and interpreting it in terms of the given time zone. But how would you take a UTC time and say, what is this UTC time in that time zone?
Sure.
That's different.
Yeah, that is different. Um, what you would be doing in that case is that you're wanting to use the AS time zone, as you can see right here.
Oh. Okay. Okay.
So overall, I think that the PyTZ is, a really good tool for helping you get your time um, sorted out, and especially in getting it to display for the users. But I think the important point is that you have to kind of take a look how most database systems store time, is that it stores it in a UTC, and then based on what your time zone settings are for your terminal is how it displays to the user. So I think that one of the big takeaways on working with PyTZ is um, use very heavily UTC timing notations internally, and then in your last steps in taking it to the user or taking input from the user, you are using the um, timing functions to get in and out of that. So that was kind of my takeaway on it, and it was, just a lot easier than some of the system level time translation pieces. Just made it kind of nice, consistent interface. Any thoughts or questions?
So realistically, even if they're doing foundation manipulation, you can just UTC for everything to UTC.
Yep, get it to UTC, because if you're working with UTC, it doesn't have that loss gain of time over the daylight savings time changes. So it keeps your time synchronization very consistent. And then when you're displaying to the user, uh, they will either have to have an understanding of magic happens at 2 a.m.
Well,
You know,
I mean, everybody can kind of, you know, daylight saving, non-daylight saving, we all know that that's when they normally.
right.
But my concern a lot of times on a day-to-day matter is if you're dealing with 2 or 3 different servers in 2 or 3 different time zones.
Yeah.
Now, the block time on the
For all
server,
of UTC.
with the clock time on any file displayed there is not necessarily what you think it would be.
Depends on your operating system.
Well,
A
Windows
lot.
is nasty. Windows is nasty that way.
Linux and Unix are really nice to work with. But their system internal clock is always UTC. File times are always UTC. And then it does stuff like this.
Right. Well, what I'm getting at is in the Windows system, that's up there. I think files go up in the future.
So, just for example, you can kind of see here, we've got the system, or if I ask for the date, it knows that I have a time zone set for my terminal as Mountain Daylight Time. But if I wanted UTC, my system already knows that. And so, you know, over here on Linux, Unix, we've got that very clearly synchronized. I don't know the programming on Windows. If I would imagine nowadays that that's got to be pretty cleared up as well. Not?
Last
Maybe?
time I saw, what was it? My mother's laptop. I can't remember what it was. Vista or 7. I know that's a little dated. Still was jumping the clock.
Huh. So,
I've never really worried about the daylight savings part. More, as I said, worried about, you know, when you have a shared server or shared, you know, directory on another server in a different time zone. And sometimes it's weird.
yeah.
Pretty sure Windows has their time servers that it syncs to pretty so often. And that's in UTC. Your personal localization is what your local clock is set to.
Right, and it stores it in CMOS's
Yeah,
and
right.
DRAM as local.
Right. Local. Not a
Which is where all the difference comes from.
Exactly. All right. Well, thank you, Dirk.
Switch over, it looks like.
Alright. Hello everybody. My name is Brett Ward. I'm going to be presenting tonight on class-based views in Django. Yeah. So more free magic provided to us by Django framework. So why use a class-based view? They provide an alternative way to implement a view. If you're familiar with Django, your classic function-based view just takes place of that. It doesn't replace it. It's just another methodology of doing it. And this gives you two main functionalities that you don't get in a function view. First is some organization and some intelligible code. This is the industry, so this isn't necessarily model view controller. That's like the sorry, the question was asked if that was if this is like the model view controller, but that is more of a how do you say that? That's more of a concept that Django kind of uses. So your models is your database, right? It's your data. Your views are your is what you see, what you render, and your controller is the server behind it, or I don't know exactly how it is in Django. It's not quite a full model view control. It's got their own adaptations. I understand it. But what class-based views is taking the views part of it. So this is how you're going to be rendering views. Right? Instead of in your views file, instead of having functions, you're going to have a class in there. And so what this allows you to do as far as organization, in a function-based view, you have to say if this method type was get or post, do this, right? So class-based view allows you to do is have a method, find a get, that will automatically get called if it's a get request. If that makes sense. And you can, obviously there's more than just get and post you can do. So that's a little bit more intelligible code. I don't know if this is a real word, but it gives you some reusability that you don't get otherwise. And then you can inherit from previous class. You can use a mix-in, which would be inheriting from multiple views, things like that. There's one caveat to multiple inheritance. As you derive more and more classes from these, your code may become harder to track because what level do you have to go back to get to your original rendering code or original piece of that. So it is generally speaking better to understand and view, but it can also get pretty chaotic if you inherit too much.
Kind of the same problem that anytime you move it up.
Right. So yeah, that's more of a object-oriented problem than anything else. But so these are some generic views provided to you by the Django framework. The base ones, and these are basically you can use these as is, and they will draw and render things. They'll render your models. They'll render a template for you. The idea isn't necessarily to just use the basic ones, although you can. It would be to take these and add your own adaptations into them, to override them, to overload them. So here's a basic example of a class-based view versus a function-based view. On the left, you have a typical function-based view. You see it's inside my view here. I'm checking if my request method is a get. Right? If it was a post, then I would have to have another else if or some other code here behind to handle that, right? So the equivalent in the class-based view is you would define your class, and inside your class you would define a method called get. And that's going to get called in the instance of a get request. And just an example of an URLs that would correlate to that is you would call your class.asView, and that would draw that. It would call this code. And you can override these. So here's an example of a basic class, and it's a greeting view class. We have a attribute of greeting, a little message, and then our get method returns that message. Right? I'm just going to print that to your browser basically. We can then override it, create a new class that's inheriting from it here, and just change the attribute greeting to another message. And then in the URL, if you were to call my instead of that, so you said greeting view as view, you get this message. If you said morning greeting view as view, you would get this message. Okay? So that's just a basic example of overriding it. You can also pass in class attributes as keywords. So this is a really nice thing to do if you want to pass in attributes. So the greeting here, we can pass it in as an attribute to this as view function and change the message in the URL if we wanted to. That's a nice thing you can do. I don't know how practical it is in most senses because you don't want to necessarily have an URL for every different version you want. You probably want to put some logic in there for time day. You can handle forms inside your class view. Here's a basic example of that. You would tell it your form class. So your form is also going to be a class. You would provide it with your template for your form, and you define your get and your post method in there, and they would handle different attributes of that view for you.
When you say the Django magic, is it the magic that it knows that it classifies?
The magic is it's parsing out the get request for you, the post request for you. You're not having to test that. It inherently knows that it's a get request, and it's going to call that get method.
Almost like this.
Right. And there are some other built-in. This is a basic generic use I'm showing you here, but there are some other ones I can update for you. For instance, you supply the model, and it will draw the attributes of the model that you specify and allow you to change. Right. That's its purpose. And it draws them in a certain way, and you can override that or overload it to draw it the way you want to. Some other things you can do are mix-ins, multiple inheritance, so you can do a lot of different things. I didn't get too far. I didn't do anything in that for this presentation. That's a little separate, more advanced topic. Another nice thing you can do is you can decorate your class instead of just your. So, for instance, if you're using the admin modules provided to you by Django, you can do the decorator on there, tell the view that has to be logged in before it can do it. Right? So you can decorate your methods inside your class individually, or you can decorate the class itself and provide it a list with the keyword arguments to which method you apply. And this is the part of the presentation where I was going to take you into Sprint. Yeah, write some models, some classes. That was not quite ready for this presentation. I will get that online for you guys, and then maybe do some other day when we have some new, more people that would want to do that kind of thing. This is my excuse why. I did want to show you. I did want to show. So, are there any questions about class-based view right now?
I've got some comments on using has anybody used reverse in Django? Let me see if I can pull up
Reverse URL.
So yeah, reverse, but you pass reverse a thing and then some arguments to the thing, and it will look up the thing and says, okay, the thing that you gave me corresponds to this view that you've declared in the URLs. So the thing can be a string, if you give your views three names when you list them out in the URL pattern. Or it can be the view function itself, which is pretty convenient. I like that a lot more because if you mistype something, you'll know when your program starts up because you'll have an import error. Whereas if you refer to things by string names, you won't know until you try to go there and it doesn't resolve the path. But there's a complication with reverse and class-based views. When you saw him put it in the URL patterns, he had the name of the class, dot, as view, and then parentheses to invoke that method on the class. And so that returns a particular instance of something and puts that instance in the URL patterns. So if you try to reverse a URL with a class-based view, what do you need to pass it? You can't pass it to class, you need to pass the as view result. So if in your code you call, my class dot as view, you're getting back a different instance, and when it tries to connect the two, it says, well, they're different objects, even though they represent the same thing. They're different objects, so it passes them over and it won't actually reverse it. So the workaround for that, and sorry I'm not online where I can type and show all of this, is when you declare your class, class my view, and then at the end of that, you might have like a lowercase, my view equals capitalized my view dot as view. So now you have a single reference to the viewified version of the class. And that's the thing that you put in your URL patterns and that you use when you try to reverse the URL.
Yeah, so like all Django docs, they have a listing of all their generic ones for you. The ones I found particularly useful are the update view. So it takes a model. Here's an example of it. Takes a model, so you specify anything, you give it that, and then you tell it which field you want, and you give it labels for them, and it will draw them for you and allow you to, and it will create a button for you. You will click your button and it will update your update database entry. You do have to send it you do have to have a form that wraps that, and you do have to have your URL that points it to it. Right? You need to pass it a primary key slug or which one you're updating. But yeah.
I think they also made some of these predefined classes that are very similar to what you get with the admin interface.
Yeah, they are.
I haven't used them, but
they do look very similar. There are some differences. Is they don't have obviously any of the admin based stuff around them, but the way that they draw very similar to what the admin would draw. So if you were to draw a model in the admin console, it would look very similar to that.
And it kind of reflects on what the passive particular admin does.
Right. Yeah. So you can say, hey, I want these attributes, and then in the update you can say these are uneditable ones, so it will show up, but it won't be able to be updated. Things like that. I haven't used them a whole lot because I am stuck in a very old version of Django. Anyway, yeah. So there's nothing else.
Yeah. Thank you.
Okay.